Welcome to qnawire.
All right, here we have a motorcyclist with some data on for each second shown in the chart, the position of the motorcyclist. And so our goal is to find the average velocity, well, actually instantaneous velocity. That's our goal. What's the instantaneous velocity of the motorcyclist at 3 seconds? However, we're going to use the data and find average velocities for different time periods, and then use that to predict our instantaneous velocity at 3. So our goal is basically approximate the velocity at 3 seconds. I'll make that a little bit more even. All right, that's our goal. Okay, so notice we have different time periods. We have 2 to 4, 3 to 4, 4 to 5, and 4 to 6. And we're going to find the average velocity. So let's figure out what's the formula we're going to use. Average velocity is displacement over time. So it's basically going to be S at T2 minus S at T1. So that's the displacement between two times. And then T2 minus T1. So I'll show you for one of these then. Let's do the time 2 and 4. So V average then would be S at 4 minus S at 2 over 4 minus 2. So we plug into our calculator. Well, let's first actually use the data and then we can plug in our calculator. Okay, so S of 4 is 79.2 minus, oops, I put S of 4 both times. I got to fix that. It's S of 4 minus S of 2. There we go. Okay. So it's a delta position over a delta time. So we'll get S of 4, 79.2. We'll subtract S of 2, which is 20.6. And then we divide by 2. And that will be in meters per second. And when we plug that in our calculator, we get 29.3 meters per second. So this will be then our average from 2 to 4 is 29.3 meters per second. Okay, so from 3 to 4, it would be the same process. I'll show you at least one more. So VAV for the second one, I'll change color. So let's do one more and then you get the idea, I think. So let's do VAV for the second interval. So that's S of 4 minus S of 3 all over 4 minus 3. So that would be 79.2 minus 46.5 all over 1. So that comes out to be 32.7 meters per second. So we can put that in our chart. Okay, so the same process of plugging into the average value formula for the different intervals will give us, then let's get a different color here. So if we went from 4 to 5, then we get 45.6 meters per second. And if we go 4 to 6, it's, let's get one more color just for variety. One more, let's try, how about brown? Okay, so that gives us, when we use the formula, we get 48.75 meters per second. All right, so now we're ready to look at approximating V of 3. And let's take a look at the data here. Since I want V of 3, one way to do a best approximation would be to approximate the average from 2 to 3, and then from 3 to 4, and then take the average of those two average velocities. So we're going to do that, but I noticed that though I have the 3 to 4 interval already, I don't have the 2 to 3. So let's do that one real quick. 2 to 3, then I'll just show the work down here. It'll be rise over run, so 46.5 minus 20.6 all over 3 minus 2 meters per second. And that gives us a value of 25.9 meters per second. So then to get V of 3, I'm going to take the average of the VAV from 2 to 3 and the VAV from 3 to 4. So notice I went a little bit to the right and a little bit to the left, and I'm going to average those two. So that will give us then, let's see, V2 to 3 was 25.9 meters per second plus the 32.7 meters per second, divide by 2, and that gives us 29.3 meters per second. And I'll still put squiggles because really we are approximating, but that's about the best we can do with this data is approximate that the instantaneous velocity at 3 seconds is 29.3. All right, I hope that helped. Have a wonderful day.